I understand.
Come in, come in. How are you? Fine, how are you? Judy, mas ainda good? Sim. Come in, come in. Manishi. Come on, say, I think 15. Ah, passou. Why can't you use mobile money? My physics. You really? Okay, so I'm going to you be coming? All right. Okay, so open the tutorial sheet for fluid non-can fluid motion. I think I sent it in the group. Oh, let me just resend it in the Telegram group. Okay, I'm sure I have it. So the exam paper, we'll go through it this coming week, a few days before the exam. Okay, we have the question paper now. Okay, let's see if we can manage to answer all the questions. So question 1 reads, a garden hose with an internal diameter of 1.9 centimeters is connected to a lawn that has 24 holes, each diameter 0.13. If the water in the hose has a speed of 0.9, what is the speed that will leave the sprinkler hose? Okay. So to start with, this is our question 1. So we shall use the equation of continuity. Okay. So the equation states that volume 1 is equals to volume 2. The idea is, if you think of it, the amount of water which goes in a hose pipe from one end is the same amount of water which will go in another end. Regardless of how thick or narrow it is. If you have a hose pipe which looks like this, and on this side is very thin, the amount of water, if 1 liter goes in here, what will leave here is also what? 1 liter. And that's why we're saying the volume at 1 is equal to the volume at 2. So now we're going to bring in the change. So we're saying the change in volume at 1 with respect to time, I can just say T, that's fine, is equals to the change in volume at 2 with respect to time. So that's just volume over a certain period of time. Then from there now, it's important to note that volume V is equals to area times displacement. Remember, area is measured in square meters, distance is measured in meters. Multiply the two, we'll have volume. So where there is V, we're going to replace with AX. So the change in A1, X1 dt is equals to the change in A2, X2 dt. dt just means over a certain period of time. Now, velocity. We know that velocity or speed is distance over time. So the change in distance over time is simply velocity. So the x1 multiplied by, where can we put the a? Let's put the a here. dt is equals to a2 the x2. It's just the same thing, just rewritten it. The a1 goes here, the x dt. a2 goes here, the x dt, like that. Then this part, the change in distance over time, is simply velocity or distance, or sorry, speed. But in this case, since it's displacement, then we're going to say A, this whole thing is just now velocity. So A1, velocity 1 is equal to area 2, velocity 2. This is the equation of continuity. So, if you want actually, there's no need of doing this, you can just go ahead and pick it up from here. Area 1, velocity 1 is equal to area 2, velocity 2. There's no harm. So now, the question says, the internal diameter is 1.9, so we'll have to do some conversions. Okay. Okay, so the idea is, let's just break it down. You have a hose pipe, this is a hose pipe, which is connected to this sprinkler. Now, this sprinkler has a lot of hose. You know how a sprinkler works, right? It has a lot of hose such that the water will be spraying out in all directions. That's what it's saying. So the amount of water going here, the amount of volume will be equal to the amount of volume of the water leaving. So how many holes have we been given? We've been given 24. So the area, in this case, will change. We shall say area 1, velocity 1, is equals to area 2 times the number of holes, then the velocity. The n that you see there is just representing the number of holes, of which the number of holes I'm talking about, these ones on the sprinkler. Okay. So area, formula of area is simply pi r squared. So let's do the substitutions. Let's bring it here. So this area that you see here, remember we're looking for velocity 2, so let's make it a subject by dividing both sides by these 2. So velocity 2 will be equals to area 1, velocity 1, divided by these 2, which is area 2 and the n number of holes. Okay, so area is given by the formula pi r squared. So velocity 2 is equals to area 1 is simply pi r1 squared velocity 1 divided by area 2 is pi r2 squared n number of course. That area is just pi r squared. Now, let's get information from the question, then we do the substitutions. A garden hose with an internal diameter of 1.9 centimeters. So at this point, it has 1.9. So that is, which one is it? Which one can we pick? That one squared over r, okay. So that is our area 1, sorry, our radius 1. Now, since that's a diameter, understand that diameter, we know that diameter d is equals to 2 times radius. Diameter is equals to 2 radius. I think I'm a radius here, to make a diameter. Now, what we've been given in the question is a what? A diameter, which is 1.9. So let's do this with the calculators. That 1.9 divided by 2. 1.9 divided by 2. What do we have? 0.95, right? We have 0.95. Now, this is still in centimeters. We have to convert it to meters. So how do we convert it to meters? Divided by 100. What do we get? (0.0095), right? Times 10 to the power negative 3. Okay. So now, first of all, pi can cancel. Pi can cancel. So radius 1 is the radius of the holes here. Radius 2 is the radius of the small hole of those holes that we have there. So first of all, pi and pi will cancel out. So radius 1. Since we've said that the radius is 0.95 centimeters, we can convert it to meters, it will become 0.0095. That's the radius as a square. Velocity 1, the velocity given in the question. Let's check, what's the velocity given? At what speed was the water moving at 0.91 meters per second? So velocity 1, 0.91 meters per second. That's the velocity divided by the radius. So this radius now is for the small hole. The radius for the small hole given in the question, it's 0.13. So again, this is the diameter. Diameter given is 0.13 centimeters. So how do we find the radius? Divide this by 2. What do we get? Divide by 2. Should get 0.065, I think. 0.065. 0.065. Now this is the radius, but remember this is in centimeters. We want it in meters, so divide this value by 100. So we should get 0.00065, or times 10 to the power negative 4 or something. Now n represents the number of holes, which is 24, like that. Now this radius is squared. Okay, so this should give us the velocity of the water. So go ahead, compute everything. Let's see what we get. Okay, so just confirm with my calculation, I got 8.1. I hope it's accurate. So 8.1 meters per second. That's the answer I got. Is it the same? What are you getting? Let me see. So open bracket, 0.0095. We close the square, multiplied by 9 point that. Okay. Okay, I think we're done with that one. Let's go to question 3. Then we'll come back to question 2. I want us first to do question 3. Let's do 3, then we'll come back to 2. Okay, question 3. The question reads, water is flowing through a tube having one end at the ground floor and the other end at the first floor, of which the height is 5 meters. The diameter of the end on the ground is 4 millimeters, and that on the first floor is 2. Find the velocity and the pressure at the first floor if the corresponding values of the ground floor are 1 and 2 times 10 to the power 5 respectively. Okay, so this is basically the Bernoulli's equation that's supposed to come to play. You have a pipe which is connected in 2 floors. So this is the ground floor. Then it goes connected to the first floor, like that. So now, this is the ground floor. So let's just draw a floor there like that, okay? So what information have we been given? We've been told that, let's do this. So we've been told that the height of the first floor is 5 meters. So the height here is 5 meters. That. Okay. So on this end, the diameter of the pipe is, let's call it diameter 1, is 4 millimeters. The water is moving at a speed of 1 meter per second. Then there is a pressure, which we'll call P1, of 2 times 10 to the power 5 pascals. Okay. On the other end, we have a diameter of 2 millimeters. We have this time around given area. Okay, so, oh yeah, that's fine. So area, or we can still come and compute it, it's fine, okay. Okay, so the question requires us to find 2 things, the velocity and the pressure. So to find the velocity, we shall use, remember that equation we used in the previous question, the one for continuity, where we simply said, area times velocity is equals to area times velocity, this one. Also known as the equation of continuity. It's the one that we're going to use. So to find the velocity first, remember this side we have velocity, this side we do not have velocity. Velocity 2, we don't have. So how do we find velocity 2? This is what we do. We can say, how can we do it? We can say the equation of continuity, which is velocity 1 times area 1 is equals to velocity 2 times area 2. That. Since we're looking for this velocity, we can say velocity divide both sides by area 2 is equals to velocity 1, area 1 divided by area 2. We just divided both sides by area 2. So how do we find the other area? Remember, area is pi r squared. But we don't have r again. What we have is what? The diameter. And this time around, the diameter is given to us in terms of millimeters. So how do we convert this diameter to, what's this? To centimeters. So to start with, what we can say is to find the area. So let's say area 2. This diameter will convert it to radius. So if it's 2, then in radius it's just 1. Now times 10 to the power negative 6 meters. What have we done here? A milli has a value to the power negative 6. A centi has negative 2. So the 2 becomes 1 because it's radius now. The 2 becomes 1. Radius 2, diameter 2 means that radius is 1. 10 to the power negative 6, these are just unit conversion. So this is radius squared, then we can say pi. Because remember, it's pi r squared. So pi times the radius squared, that's what we get. So we'll leave it at that. Same thing will happen here. Diameter is 4, meaning that radius will be what? 2. Hence area 1 in this case will be equals to 2 times 10 to the power negative 6 meters in brackets squared times pi r squared. Now let's do the substitutions. So velocity will be equals to, what's the velocity 1 given? It's 1. So that's just 1. Area 1 given. Area 1 given is simply 2 times 10 to the power negative 6 in brackets squared. We have a pi there. Divided by area 2 given, 1 times 10 to the power negative 6 in brackets squared. We have a pi. So it's evident that the pi and the pi will cancel. This is just a 1. So just divide these two values. What do we get? Nada. Monitor. So if your computation is accurate, your answer should be 2. Velocity 2 should be equal to 2 meters per second. Why 2, not 4? You found 4. Let me see. What you found? Oh, let me see. So we're saying, no, tutorial sheet for fluid mechanics. Negative 6 squared divided by the power squared 4. Yeah. So the velocity should be 4, not 2. Okay, so now that we have a velocity, which is 4 meters per second, let's find the pressure. Remember, pressure this side is 2, so we need the pressure on this side. So to find the pressure, it's evident that we're going to use the Bernoulli's equation. So Bernoulli's equation is given as P1 plus half rho velocity squared like that plus rho gh, which is equals to P2 plus half rho velocity squared plus rho gh. This is the Bernoulli's equation. Okay. So pressure 1 we have. Density rho, this is water, so density we use 1000. This rho gh will equate to 0 because this height 1, remember we have two heights, right? This, on this part of the pipe is on the ground floor, so the height is 0. This side, the pipe is 5 meters, not 10 meters, sorry, it's supposed to be 5 meters. It's 5 meters above the ground, so the height here, h2, we're going to use 5. So let's do the substitutions. So density, pressure, we're using 2 times 10 to the power 5 pascals plus half. Density, we're using 1000. Velocity 2, what is our velocity 2? Velocity 2 is the one that we found here. 4, right? So velocity 2 is 4, then it has a square. Plus, this part will give us a 0. Why is it giving us a 0? Because this h, like I said, height there is 0, but height here is 5. So this is equals to pressure 2, that's what we're looking for, plus half, again, no, sorry, made a mistake. This is supposed to be velocity 1, then this is velocity 2, right? So for this velocity, instead of 4, we're going to use 1. Is that okay? Then on this other side, we have half rho against 1,000. Velocity, this is when now we use the 4 squared plus. Now this part, we have rho gh. Rho gh, that's just density times acceleration due to gravity times the height. The height being 5 meters. So density 1,000, g 9.81, that's acceleration due to gravity. H, the height is simply 5. Okay. So let's do it together, my people. This is what I want you to do. This is amounting to 500. This is just 1, forget about it. Half of 1,000 is 500. So what is 500 plus this value? Add these two. 500 plus this value, what do we get? Let's do it together the simple way. 5,000 plus 2 times 10 to the power 5. Come again? 200,000? So, to be like this, 200,000 plus 500. So this is equals to pressure 2. Now, if we come here, this is just 4,000. Half of 4,000 is 2,000. So compute this 1,000. So just 5,000 times this. What do we get? Find this value here. What are we getting? Times 5. 49,050. Is it? So 49,050. That's what we get. Now, so get 200,500 is equals to P2. If we add these two values, we're going to get 51,050. We just added these two, right? So what next? This guy crosses the equal sign. So 200,500 minus 51,050 is equals to P2. So subtract these two. What do we get? So that's our answer. That's the pressure 2 we're looking for. So if my calculations are correct, should get something like this. 149? 450. Yes. Now these are pascals. Let's put it in standard form because they are given in standard form. So in standard form, this will be pressure 2 is equals to 1.5. We round it off. How many zeros? 1, 2, 3, 4, 5. So times 10 to the power 5 pascals. Very simple. Okay, that was question 3. Okay, I've seen a similar question on this one. Let's do question 4. We'll come back to 2, don't worry. Let's do 4. Question 4. Question 4. A liquid of density 800 is filled in a large vessel open at the top. The total pressure at the bottom of the vessel is 2 atm. If a hole is made at the bottom of the tank, find the velocity of efflux through the hole. Okay. So, what's the information given to us? Number one, this is question 4. Number one, we've been given density, right? So density 800 kilograms per cubic meter. What else? Pressure. What's the pressure given? 2 atm. Okay. Now here's what you need to know. 1 atm is equivalent to 101,325 pascals. Meaning that 2 atm is equivalent to, just multiply this value by 2. What do we get? 202? 202, 650 pascals. So that 2 atm is equivalent to that value. Okay? Now, let's understand the question before we answer it. It's not about the answer, it's about understanding the solution. It says a liquid of density 800 is filled in a large vessel, open at the top. Let's draw a rough vessel. This is our vessel. So we're saying that it is open at the top, something like that, okay? Then a hole is made at the bottom. So a hole is made at the bottom, somewhere here. A hole is made. Meaning the liquid will start flowing, of course. So the total pressure at the bottom of the vessel is 2 atm. So the pressure here, so you can say pressure, let's call it 2, is 2 atm. So what is the velocity of efflux? Okay, let's first bring in the, what's this? The Bernoulli's equation. Bernoulli's equation is P1 plus rho, or rather half rho V1 squared plus rho GH. Rho GH1, this is equals to P2 plus half rho V2 squared plus rho G, what am I doing? Rho GH2 is what we have. Okay. So let's consider it in this way. Velocity 1 can be the velocity that leaves at the bottom here. So this is, you can say this is velocity 1. So we're looking for. Let's call this pressure 1 instead of pressure 2. Then the water inside will have pressure 2, the opposite. So from what we have, remember, the water was in this vessel. This water was motionless. Is that okay? So since it was motionless, what will happen to its velocity? It is 0, right? It was motionless. So since that velocity of the water is 0, this guy will cancel out because we don't need the velocity 2. This is 0. That's 1. 2, let's put the pressures together and the heights together. This is what we're going to have. Let's put the pressures together. So pressure 1 minus pressure 2. This one comes aside. Then plus this guy, which is half rho velocity 1 squared. This is equals to, on this other side, let's have rho GH2 minus this guy, which is rho GH1, like that. So we need to get rid of this K2, this 2 here. How can you get rid of this 2? We don't divide, we multiply. Multiply everything by 2. So if we multiply this by 2, this by 2, this by 2, this half will cancel out, right? So we can say let's multiply the whole equation by 2. So if this multiplies by 2, what do we get? 2p1 minus 2p2. This times 2, the half will cancel. So plus rho v1 squared like that times 2 rho gh2 times 2 rho gh1. Let's factor out what is common on this part. 2 is common, so we can have 2, open bracket, pressure 1 minus pressure 2, plus rho, like that. Same thing here, let's factor out what is common. Now here, if you look at this part, what is common here is 2 rho g. What remains? h2 minus h1, like that. I hope that's okay. Yes. Because the water is in the oasis, in this vessel. It's not moving. But at this end, it's starting to move out of the vessel. Let me do this. It's supposed to be at the bottom here, like this, something like this. You understand? Here, the water is not moving, it's just stationary. But once you start living on this hole, then it will have a certain velocity. It's as good as putting water in a bucket. It's not moving, it's motionless. That's why the velocity is 0. Okay. Let's make this guy the subject of the formula. To do that, we're going to push this guy to the other side. What do we get? Rho, velocity 1 squared, is equals to 2 rho g, open bracket, h2 minus h1. So this will cross the equal sign to become minus 2 p1 minus p2, like that. We're making velocity the subject of the formula. What will happen if we divide throughout by rho? This is what will happen. So velocity 1 squared is equals to 2g minus 2 p1 p2 divided by rho. Have you seen what has happened? Remember, if we divide this by rho and this rho will cancel for this part. If we divide the rho here, there's no rho, so the rho, that's why you have it there. But on this part, even if you have rho, it will still cancel this rho. That's why I didn't write it there. Okay, let me kill this. So since we're making velocity the subject, now we can introduce a root to get rid of the square. So that we have velocity is equals to the square root of 2g h2 minus h1. Then we can say minus 2 pressure 1 minus pressure 2 divided by rho, like that. Okay. So when calculating the velocity of efflux, it's important to note that the pressure is the same. So I can say for velocity of efflux, the pressure is the same. This simplifies things. When we say the pressure is the same, what will happen to the pressure? If P1 and P2 are the same, what will happen? It will just be 0, right? So it will be 0 times 2, 0, divided by rho, 0. So what remains then? What will remain is simply the square root of 2g h2 minus h1. Because pressure is the same, so pressure will cancel out. So that's what will remain with. So H1 and H2 is representing the height of the vessel. So we can simply say H is equals to H2 minus H1. When I say H2 minus H1, we mean the highest point minus the lowest point, of which the lowest point is at the bottom. So H is simply the height of the vessel. So where there's H1 minus H2, we can write here, we can say since H is equals to H2 minus H1, the height of the vessel, then this is equals to 2GH. Simplifying things, H1 minus H2 is simply just H. Now, the formula for pressure that we're going to use is simply that pressure is equals to rho GH. This is where it gets interesting. Let's do this part. Okay, so pressure, the formula for pressure. We can say since pressure, the formula for pressure is given by rho GH. This is the formula for pressure. What we want to do, we have to substitute the G and the H. How do we do that? Let's divide both sides by what? By rho. If we divide both sides by rho here, what do we get? We get pressure divided by rho is equals to GH. Is that okay? So that GH that we have in that formula now, we can substitute with the pressure over rho. So that we say velocity is equals to the square root of 2, where there's GH, we replace it with the pressure over rho. That's it. Pressure we have. Rho we have. Now we can find what we're looking for. So velocity will be equals to 2 times the pressure. The pressure is 202,650 divided by rho, which is 800. And remember, everything is under a root. So what's the value of the velocity? What's the value of the velocity? $22.5. You need to put the square root. So the final answer is simply 22 meters per second. That's our final answer. I'll give you the solutions. You can capture them so that you can go through. Okay, let's go back to question 2 now. Let's answer question 2. I hope this one is okay. Which tutorial should we do next? Waves. Which one? Waves. There's sound, there's light, then there's waves. All those are waves. Which one should we start with? Sound? Light is okay. Okay. Let's do question 2. Question 2 is very simple. Calculate the rate flow of glycerin of density. So we've been given density. So density rho, this is question 2. Density 1.25 times 10 to the power 3 kilograms per, we've been given in terms of seconds, okay? No. So density is supposed to be there. Okay. Then through a convex section of a pipe of radius, so radius is 0.1, area 0.1. What else? On the other end, so this is R1, so R2 will be given 0.04. The pressure drop across its length is 10. So pressure is 10 newtons per square meter. So Newton per square meter is just the same as a Pascal. Okay. Now, when we say the pressure drop, what does it mean? Pressure drop. Any idea? Huh? Reduced? Yeah, you can say reduced. But in this case, since we're saying the pressure drop is 10, or when someone says the temperature drop is 2, it means that the difference between the two temperatures is what? 2. It dropped 2, it can be degrees or whatever. Is that okay? So the difference is 2, that's a drop. Meaning that temperature 1 minus temperature 2 is 2. In this case, pressure 1 minus pressure 2 is what? 10. This is the pressure drop. It's not pressure 1 or pressure 2, it's the pressure drop. So we can say this is pressure 1 minus pressure 2 is 10. Okay. Now, there's something very important that you have to take note of this question. Something that will help us. Where is that part? Okay, that's fine. So this time around, consider it like this. This is the ground. On this ground, we have this pipe from one end to another. So this pipe of ours, on one end, it has a radius of 0.1. On the other end, it has a radius of 0.04 meters. Now, if you look at the pipe, it's not raising or dropping, it's just on level ground. Is that okay? So what does that mean? It means that the height here is 0. It's on level ground. Same thing here, the height is also what? 0, because it's also on the ground. Then the temperature drop, the pressure drop is what? 10, meaning that the difference between the pressure is just 10. So let's see how we can find, what are we looking for? The rate flow. Okay, so to start with, to find the rate flow, we need to find velocity 1. Let's see how we can do that. Do we have velocity 2? Okay, before we come to that, let's bring in Bernoulli. Pressure 1 plus half rho V1 squared plus rho GH1 is equals to pressure 2, this is equals to plus half rho V2 squared plus rho GH2, Bernoulli. Now, our Bernoulli guy, where there's height, we just cancel. Why? Height is 0. H1, H2 is 0, so height cancels. So this guy disappears, this guy disappears. Like we said there. Let's put the pressures together. So, pressure 1 minus pressure 2, that guy comes this side, is equals to half rho V2 squared minus this guy goes that side, which is half rho V1 squared. Remember, the pressure drop is what? 10. So where there's P1 minus P2, we just replace it with what? 10. So this will be equals to, we can factor out something is wrong. Something is wrong. This is not G. This is rho. Okay. We can factor out what is common, which is half and rho. What remains? V2 squared minus V1 squared. Like that. Okay. We've been given the value of rho, by the way. The value of rho is this guy here. This is what I want you to do. I want you to multiply half times rho, then divide it both sides. So you divide it by 10 on this side. So on this side, we just have V2 minus V1. So rho times half, then divide by 10 to the other side. I want to get rid of it in short. So do the Do the dividing and multiplying. So half times rho, the answer that you find, you say 10 divided by that answer. What are we getting? 62. Are you sure? 0 point? Yeah. 62. How? So 0.016. So we're saying V2 squared minus V1 squared is equal to 0.016. Like this, eh? Okay. Let's call this equation 1. Come back to it. Let's leave it hanging. Remember the equation of continuity, which says area times velocity. Area 1, velocity 1 is equal to area 2, velocity 2. So area 1, velocity 1 is equal to area 2, velocity 2. The equation of continuity. Now we're going to do the substitutions. We know that area is pi r squared. So where there's area, for this one, we'll say pi r squared is 1 and velocity. This is equals to this guy, pi r squared, this is 2, and velocity. That's what we have. We can get rid of pi. If we divide both sides by pi, pi will just disappear. What do we remain with? R squared is equals to R2 squared. Okay. So, yeah, it's R1. It's R1. Okay. Then now, let's divide both sides by, want to create a ratio. Divide both sides by V2. So this is what I want to do. I want the V2 to come here. I want the R1 to go there. Is that okay? The V2 will come here as a denominator. The R1 will go there. This is what I mean. V1 over V2. I've divided both sides by V2. If I divide both sides by R1, what do we get? R2 over R1. Like that. Now, since R we have the values of R, so we can do it like this. We can say V1 over V2 is equal to, what is R2? Four? Okay. So, are you sure? Remember there's a square. Everything is giving you 4. Why do I have this value? Yeah. Mine is 0.16. How are we finding 4? It's supposed to be 0.16, eh? 0.04 divided by 0.1, then squared. 0.16. So, velocity 1 over velocity 2 is equals to 0.16. We cross multiply, hence velocity 1 is equals to 0.16 velocity 2. That's what we get. Okay, remember the pipe that I drew? So we're looking for the velocity on the other end. In short, we're looking for velocity 2. This is just an expression for velocity 1. So we're going to use this. By the way, this is our equation 2. So this is what I'm going to use to substitute here, and then we can find the value of V2. Simple as that. That equation will come in here, then we'll find V2. Let's do it. Let me just, we're done with all this information. All this, we're done. We just do this equation. This is what I said. This equation, where there's V1, we'll substitute with that. So that it becomes V2 squared minus, where there's V1, we'll put 0.16 V2, like that. Put it in brackets because there's a square. Squared, this is equal to 0.016. That. So I've just substituted. So that equation into this one, we'll get this. What is 0.16 squared? 0.16 squared. Zero point? 0.0256 V2 squared. This is equal to 0.016, like that. Now, these two are like terms, V2 squared. So just say 1 minus this decimal. What do we get? 1 minus this decimal. What do we get? What do we have? Okay, 0 point, like this, V2 squared, 44, okay. This is equals to 0.016. So divide both sides, then square root to get rid of the square, then you have the velocity. Do that. Divide both sides, then you square root, so to find the value of V2. And that's our answer. .8? Have you introduced a square root as well? Yeah. Mine is different. Start with that other one. 0.016 divided by that one. Yes. Yes, that's my answer. So my answer is 0.128. I hope that's okay. So 0.128 meters per second. Okay, so I think we've answered 5 questions so far. For the rest of the questions, they are just straightforward. I'll give you the solutions. I think for now we are done. So I'll capture them, then I'll send them. Yes. Benoli? Yeah.
The question is visit. Why calling it?
It's the symbol.
The difference between ones.
No. Not that there's a difference. How can I put it? It's just a symbol. Just like, for example, we say P is equal to pressure, right? This is just a letter. So even rho is just a symbol. The name of this symbol is rho, and it represents density. Just like the name of this letter is P, and it represents pressure. Is that okay? No. No, those are just Greek letters, like the alpha, the beta, the gamma, the lambda, just Greek letters. So I'm just using rho because that's the name of that particular symbol. It's not P, it's rho. So if I say P, we'll make a mistake. We'll confuse it with pressure. That's why I'm saying rho and P. There's a difference. Just simple. Don't worry. Me question, but what is rho? Okay, we're done for now.